All right, last time in the last video, we did the first two examples that are on the section 3.2 page. So we did both those graphs. That was simply a review of what we already did in the last unit, being able to take the graph of the parabola and translate it and stretch it and reflect it. So I don't know that we're going to graph all of today's examples. We will do some of them time permitting, but here's what we're going to do. We are going to talk about, okay, we can graph when it's in what I call vertex form, meaning we can see the translations, but what happens if the quadratic equation is in what's called standard form? So let me define that for you first, and then we'll go. So section 3.2 quadratic functions, you'll see a little space where you can go ahead and write down this definition. And so here we go. For any real numbers, A, B, and C, with the added detail that A is not equal to 0, then we're going to call it P of X is equal to AX squared plus BX plus C is a quadratic function. In standard form. That's the standard form of quadratic function. While you're writing that down, I just want to mention to you the reason that we have this detail that A is not equal to 0. Well, A is the number in front of the x squared. And if A was 0, then we wouldn't have this term and we'd no longer have a quadratic function. We would have a linear function. So that's why there's that caveat there that the leading coefficient, meaning the value of A is not 0. So as we saw in the first couple of examples that we did at the end of last time that were on the previous video, we know how to graph something, and we already did this. We're not going to do it again. We graphed this. F of x is equal to x minus 4 squared minus 3. And hopefully it was universal that we saw that this minus 4, it moved the graph right 4 units. This minus 3 moved the graph down 3 units. And that's what we had. Now, here's today's question, and this is how we're going to extend it. We're going to spend most of our time in this section doing the following. What happens as in example 1, where I have this function, f of x is equal to x squared plus 6x plus 5. So no longer is it grouped, and do I have something in parentheses squared, and I can't just say, oh, this plus 5 means move it up 5. That's not at all what's happening here. So note, the first thing I need you to see is the difference between this format of the equation, which tells me straight away what the translations and stretching and shrinking are, and this equation, which is in standard form. And you're going to see this a whole lot. So what our goal here is we want to take this and we want to turn it into this right here. And so I'm going to show you a little process. This is what you're going to do every time. Okay, so if you don't have this, you can watch the video later or look on somebody else's paper and get it afterward. It's just the definition that you can find if you go into the e-version of the book that's in my math lab. And so what we're going to do is this process, which is called completing the square. It's called completing the square because what we want to do is we notice here that I have this parentheses. This term right here is squared. And so I want to take this and put it in this same format. And just to avoid confusion, now I'm going to erase this because that's not the answer. Okay, this is going to be a completely different thing. I just want to show you the difference between standard form and vertex form. So here's the first thing you're always going to do, no matter what. Okay, so step 1 is going to be, you're going to group the terms with the x's. You're going to group the terms that have the x's. So what that looks like over here is I'm going to use some parentheses, and I'm going to put parentheses around the x squared plus the 6x. I'm going to leave a little space here, and then the plus 5 doesn't have an x. I'm shoving it to the outside. If I'm going through these steps and you don't understand what I did over here when I write the step, all the problems we do are going to be the same. Okay, so once you see it once it clicks, it's going to be the same every time. Yeah. Okay, right. So the first thing I'm going to do is I'm going to group the terms that have the x's in them. That's going to take me to step 2. Now step 2 is going to be easy to write for this problem. We're going to leave it blank. Step 2 is going to apply to what happens when I have a number that is not 1 in front of the x squared. Okay, this is the simpler situation. Simple doesn't mean easy. This is the simpler situation where the next example that I do will have a number in front of the x squared. So just leave that blank. We'll come back to that. Step 3. This is the actual completing the square term. What I want to do is I want to put a number here in the parentheses that will make this a perfect square trinomial, meaning if I factor this, I get the same thing times itself. So here's how you do that. Okay, you're going to take 1/2 You're going to take 1/2 the coefficient of x, or you could just say 1/2 of b if you realize that that's b in the standard form that I wrote up here earlier. Okay, that would be quicker. So you're going to take 1/2 of the coefficient of x, and then you're going to square it. So you're taking 1/2 the coefficient of x, then you're squaring it. So everybody identify for me, what number am I going to take half of on my problem here? 6. What's half of 6? Okay, I'm just going to write this. This is my scrap work. You don't have to write this if you don't want to. Half of 6 is 3. And what do I get when I square 3? I get a positive 9, right? It's always positive. So I'm going to put a plus 9 right here. Now, if you remember your factoring days, notice what I've done. The two factors of 9, 3 and 3, right? That we just squared 3. 3 times 3 is 9. What do the two factors of 9, 3 and 3, what do they add up to? Ah, perfect. So we'll factor this in a minute. I'll do that whole thing. You don't have to do that. Here's the last step. And then the rest of it is just a little bit making it pretty. The last step is you've got to keep the function balanced. Okay, so we've got to balance the function out. And what I mean by that is I've added 9 in the parentheses. I have now created something new. Okay, that 9 was not there before. Okay. So if I've added 9 here, what would you suggest I do out here to keep everything balanced, to keep the net result 0? I've added 9 here. What did you say? Subtract 9. That's going to be the reverse. So I'm going to subtract 9. And if you're saying why? Well, what does 9 minus 9, what does that end up being? 0. I've not changed my function at all. That's what I mean by keep the function balanced. I'm going to erase my scratch work right here. Now we're just going to make this look prettier. We're going to make it look like it's in vertex form. So f of x is equal to, let me grab a different color just because I can. X squared plus 6x plus 9. Just remembering your factoring days. The two factors of x squared are x and x. What are the two factors of 9 that add up to 6? Those would be plus 3 and plus 3. And so if I have the same factor times itself, x plus 3 times x plus 3, then that becomes x plus 3 squared. You don't have to write down what I wrote in red. Probably after you do 1 or 2, you'll realize what it is. But I just want to make sure that there's no concern about where I pulled this out of. And then plus 5 minus 9. Plus 5 minus 9 is -4. Now we're not going to. We'll come back. I want to make sure we have time. We're going to do all of the completing the square parts to these problems, and then we will come back and we will graph these problems, or some of them after, but there are a few things that I want to talk about. And so this on the next page, this is exercise 7, and we're going to do this for all of the problems. We're going to answer these questions now that it's in vertex form. So the first thing that I want to know is, what's the vertex? The vertex is just another way of saying, which way has this been translated, or which way, what's happened to this? So what does this +3 tell me happens to the graph? It goes left 3. What does this -4 tell me happens to the graph? It goes down 4. That's true. So the vertex, I'm going to use a V for vertex in front of my point right here. The vertex, if I move my vertex of the basic x² function left 3, down 4, what's the new point of the vertex when I go left 3, down 4? -3, -4. Left 3, down 4. That's my vertex. The next one, the domain and the array. You know what? We'll come back and we'll graph this. It's easier to do all this from the graph. So we'll come back. That's the vertex. We'll do at least one problem where we graph it so we can answer those questions as well. So pause there on that problem. What I would like you to do now is the problem that's right beside it, which is labeled exercise 3. I would like you to go through that and complete the square and identify the vertex. And if you get to that place, you're good. All right, x² minus 8x plus 10. If you're still working, finish up the job. I'm going to get started. So the first thing on my steps, and hopefully the first thing you did, is you grouped the x terms, or the terms with the x's in it. So x² minus 8x, I'm going to put in some parentheses. And then the plus 10, I just slide to the outside. I don't do anything but stretch it out a little bit. Step 3, which our eventual step 3, what's the term that I'm going to look at to take half of? The 8. What's half of 8? 1/2 of 8 is 4. What do I get when I square 4? So I'm going to add 16 right here. Now I have changed my function. So what do I have to do out here to keep my function balanced? I've got to subtract 16. Yes. Fantastic. So this is f of x is equal to, so I've got x² minus 8x plus 16. What are the two factors of 16 that add up to -8? -4 and -4. So I've got x minus 4 squared. And then 10 minus 16 is -6. So again, tell me what two things have happened to this. The -4 tells me the graph goes right 4. The -6. Down 6. So that means my vertex is right 4 and then down 6. Excellent. Just because I want to make sure this is solid, flip over to the back of the page. I didn't put an extra example, but we're doing real good on time so far. I just want to make sure that we do another one of these simple. Remember, simple doesn't mean easy, but I want to do one more of these simpler examples just to make sure you're feeling it. So please do this. Let's go x squared. Let's do plus 12x and then do minus 8. Go ahead and write that in the vertex form and just tell me what the vertex is. First thing I'm going to do is group the terms that have an x in them. So the x squared plus 12x gets grouped. The minus 8 gets thrown outside. So tell me, what am I going to add right here? And you got the 36 because you took half of 12. What's half of 12? 6. 6 squared is 36. And since I added 36 in the parentheses, I now need to keep it in balance and subtract 36. What two factors of 36 add up to 12? Well, that should just be, by the way, that should always just be, what we put right here should always be that number that you took, when you got half. Half of 12 was 6. There you go. 6 times 6 is 36. 6 plus 6 is 12. And then negative 8 minus 36 is minus 44. So the vertex, how far do I go in the x direction? Negative 6, left 6. How far do I go in the y direction? Down 44. We don't have, our graphs aren't big enough for that one. All right, so that's what you do when there's a 1 in front of the x squared. Now, the next part of the process is not really any more difficult. You just got, when you get to the keeping the function in balance, you just got to make sure that you remember that there was a number in front of the x squared. And I'm going to tell you what I mean by that right now. So the next example, this is the top of page 2 of the sheet that I gave you. It looks like this. F of x is equal to 2x squared plus 4x minus 7. So just because I want to make sure we're all awake this morning, does everyone recognize that there's a number in front of the x squared that's not 1? You with me? You can see the difference between this problem and the 3 previous ones we've done, right? Okay, that's important. Okay, so now we're gonna fill in step 2 here. So step 1 is the same. Let's group the terms that have the x's. So 2x squared plus 4x, I'll leave a little gap, and then I throw the minus 7 outside. Here's step 2. Step 2 is whatever the value of a is, factor it out. Okay. So factor out the value of a, or you can write out factor out the leading coefficient is another way to say that. It's always whatever's in front of the x squared is what you're going to factor out now. And I'm just going to factor it out. The reason I grouped the x's first is I don't care about this last term right now. So don't worry about factoring anything out of this last term. It's only out of the stuff that have the x's. So that looks like this. F of x is equal to, I'm going to throw the 2 outside the parentheses. When I factor the 2 out of the 2x squared, what's left? X squared. When I factor the 2 out of the 4x, what's left? Okay. Leave a space here. And then the minus 7, I've not done anything to that. It stays minus 7. Everybody still tracking with me? We doing okay? Now the next step's the exact same thing we just did. So tell me, what would you propose that I should add right here? 1. For anyone who wasn't quite there yet, here's where we got that. What's half of 2? Half of 2 is 1. 1 squared is 1. Same process. All right, here's the thing that I need you, listening ears, as your kindergarten teacher probably said. Here's the listening ears, because now we got to keep the function in balance. Now, some of you, I'm sure you did, because sometimes students do this on tests, and I want you to avoid this. Don't just write a -1 out here, because that's not how much we've changed the function by. Because what's outside the parentheses? 2. If I was to distribute this 2, which we're not going to, but if I was to distribute this 2, I have 2x squared, I'd have 4x, but what would I have here? If I distributed the 2, I would have what? Plus 2. So to keep this in balance, what do I have to do here now? Subtract 2. So that's the key. Understanding why, hey, Mr. Perkins, why did I added 1 here? Why didn't I just subtract 1? And the reason for that is because of this 2 that I factored out earlier. Okay, that changes it. 2 times 1 is, I really changed it by 2, so I subtract 2. Now the rest of this is gravy. It's just what we did before. So here we go. We got 2. What are the 2 factors of 1 that add up to 2? That's 1 and 1. And then -7 minus 2 is -9. So my vertex. What's the first thing that happened to my vertex? What does the +1 tell me? Left 1, so -1. What's the second thing that happens to the vertex? Down 9, so -9. There's my vertex. We'll come back a little later and we will go ahead and we'll probably graph that one and one of the others. We'll answer some of these other questions. What I would like you to do in the meantime, I'm going to leave that one up there as your example. I would like you to do exercise 5. That's right next to it. F of x is 3x squared plus 12x plus 6. And tell me what the vertex is. All right, I'm going to get started. If you're still working, that's okay. I see it looks like the majority of you are not writing, so I hope that's a good thing. And if it's not, I hope you ask me a question. So step number 1, I'm going to group the terms that have the x's. Do not factor until you've grouped it. I know the temptation is, oh, hey, I can take a 3 out of 6 too, but now you're just complicating things. Okay, this 6 is going to go outside the parentheses. That's where we want it. So I'm going to group the things that have the x's first. Now, since I have a number in front of the x squared, I'm going to factor that number out. So I'm going to factor out a 3. When I factor the 3 out of 3x squared, I'm left with x squared. When I factor the 3 out of the 12x, I'm left with 4x. And then the plus 6 is outside the parentheses, so I do not factor anything out of it. What am I going to add right here in the parentheses? Not 2, 4. Half of 4 is 2. So those of you who said 2, that you're halfway there. Half of 4 is 2, but I got to square it. So 2 times 2 is 4. Now again, be real careful. Don't just subtract 4 out here, because I've got to take into account that I have this 3. And what's 3 times 4? 3 times 4 is, I've really added 12 to this problem, so I have to subtract 12 out here. And now the last step is to just make it look pretty. So f of x is 3, and then I have x plus the 2 factors of 4 that add up to 4 are 2 and 2, and then 6 minus 12 is negative 6. So tell me, what's the vertex? I've moved left 2, I've moved down 6. Exactly, perfect. One more, exercise 6, and be real careful of the signs. That's the hint of the day. All right, so while I rewrite my f of x here, what's the number in front of the x squared? Negative 2. Okay, so let's be careful of our signs. That's going to make a difference. And if you missed something, that's okay. That's why we're doing examples. Okay, so then you have all these worked examples. When you go to do your homework, you can just compare step by step. So first thing I'm going to do is I'm going to group my terms that have my x's. So the negative 2x squared plus 12x. The negative 13 is outside the parentheses, waiting for something to happen. Now, you just told me the number in front of the x squared was a negative 2, so I'm going to factor a negative 2 out. Fantastic. So when I factor negative 2 out of negative 2x squared, what's left? Hey, just the x squared. Now, here's the first question of the day. When I factor the negative 2 out of 12x, what's left? Negative 6x. Great work on the signs. A negative times a negative is a positive. Fantastic. So now what do I add here in the space? Okay. Half of negative 6 is negative 3, but when I square negative 3, I get positive 9. I heard it. That sounded great. Here's the second question of the day. What have I really done to the problem? Don't worry about what I'm going to do out here. I've added 9 in the parentheses. What have I really done to the problem? Not added 18, added negative 18. Remember, it's a negative 2 times a positive 9. That's negative 18. So what do I have to do out here? Positive 18. Careful of that sign. It's the exact same process. You've just got to be careful of the sign. I get it. I understand how that can be confounding, and that's why we do the example. Now we're going to finish this problem off, and you're going to tell me what the vertex is. So negative 2. The 2 factors of 9 that add up to negative 6 are negative 3 and negative 3. And then negative 13 plus 18 is plus 5. So my vertex, what's the x coordinate of the vertex? Positive 3, because we went right 3. What's the y coordinate of the vertex? 5, because we went up 5. Excellent. Now what I would like you to do is go back to the first page and go to example 1 and exercise 3, both problems at the bottom, and I want you to graph both those. And then we're going to answer some key questions about them, and then we'll graph 1 or 2 of the other ones too. You told me a moment ago that the vertex of example 1 was negative 3 and negative 4. In case you need it, and it's totally good if you do, I've put the basic function here. My x squared function is in dotted pencil, and I'm going to take the whole thing and I'm going to go negative 3 and then down 4. That's where the vertex goes. And the way I like to graph, this is just the way I've remembered it, it's not necessarily the way you have to remember it, is there's been no stretching or shrinking. So I'm just going to pretend that this orange dot, that's my vertex, that's the origin. And so when I'm going to go over 1 and up 1, I'm going to go over 2 and up 4, and I'm going to go over 3 and I'm going to go up 9. And I'm going to do the same thing backwards. These are just my basic points, and I'm graphing them, and I'm pretending that the vertex is my origin. We've not had any stretching. So there's my basic graph. Now here's some questions. The next question we're going to ask is, what's the line of symmetry? Okay. Well, we talked about the line of symmetry. You can see, hopefully, dotted. Let me make it a little darker. I know that maybe on the overhead it's not super visible. Here's my basic function, and we talked about the symmetry of this basic function. What line is this graph, the pencil graph, symmetric with respect to? The y-axis, right? And the equation of the y-axis is the x values are all 0. So when we ask about the line of symmetry, what we're asking is now, how far left or right has this gone? What's the new line that divides my parabola here in half? So I'm just going to draw, you don't have to do this on your page. I just want to show this is the line here, it goes right through the vertex, it cuts the parabola in half. And that line right there, what is it? It's what x value is it? It's x equal to what? Yeah, the line of symmetry is always just the x value of the vertex. Okay, so now if I fold my graph along that line that's at x equal to negative 3, like it's a Valentine's Day card, then I have the same thing on both sides. What's the domain and the range? So of my orange function, the domain. Well, the domain doesn't really change with my parabola. How far left does the orange graph go? How far right does the orange graph go? It's the range that gets interesting. What's the low value of the orange graph? What's the high value of the orange graph? Okay. Related to that domain in the range is what a new term, maximum or minimum. What does the word maximum mean? The most, the greatest. What does the word minimum mean? Smallest. Okay. So this graph that I have in orange, which one does it have? Does it have a maximum value or does it have a minimum value? Yeah, it has no maximum, it goes up forever. But it has a minimum, it comes down and stops and then it goes back up. Why does it have a minimum? Which way is this graph pointing? It's pointing up. Now let's think about our stretching and shrinking and everything. What about this graph, what about this, or what about this tells me, even if I didn't graph it, what tells me that this graph is pointing up? The A value that we factored out or would have, but the A value is positive, it's 1. And so that means it's pointing up. So you can know right away without graphing whether a function or a parabola is pointing up or down. So that means that this graph right here, since it's pointing up, it has a minimum. And when you're asked what the minimum value is, you're being asked what's the minimum y value? And it's kind of related to the domain. The minimum value is equal to -4. Just for time's sake, we're not going to, I guess I did ask you to graph this one, so I will go ahead and graph it real quick. So this one, we already said the vertex is 4 and -6. So that means it goes over 4 and then it goes down 6. There's my vertex. There's no shrinking or stretching that's been done to this graph. So I'm just going to do my basic points, pretending that the vertex is my origin. And so here's the graph. And so let's answer those questions again. What's the line of symmetry? I'm going to abbreviate the LOS. The line of symmetry is x equal to what value? Oh, I accidentally did it on 3. I'm sorry. I don't want to make a huge mess of this graph. It should, well, I'm going to do this. I can't count. It happens when we get old. Sorry, everybody. I've got to move the whole graph over one more. I messed up. I apologize. The red graph is the right graph. The blue one is just a fun little parabola sitting there. Actually, nice, looks cool, looks three-dimensional now. Okay, so now what's the line of symmetry of the maroon graph, the actual correct graph? Okay, yes, you said that before, and that's how I knew that my graph was wrong. Yes. The line of symmetry is x equal to 4. I'm having a day. I wrote x equal to twice. Good job, Krister. Okay, so let's move on from that problem. It seemed definitely difficult. What's the domain of the red graph? Yeah, that's going to be the same for all the parabolas. The range, what's the low value of this graph? Infinity. Whoops. And so this graph right here, it's pointing up. That means it has a maximum or a minimum? Okay, it has a minimum. And what is the minimum value? We're going to graph one more. We're going to graph actually the last one, but before we do, this problem right here, example 2. Which way is this graph pointing, up or down? How do I know it's pointing up? Positive 2. So that means if I was to ask you what the maximum or a minimum is, it would have a minimum. And actually, it would be -9. That's the vertex. Which way, exercise 5, which way is exercise 5 pointing? Again, up, same reason, it's going to have a minimum. And so just so that we do an example of it, I'm going to give you a minute or so. I want you to graph this last one, which is exercise 6. It's being stretched. It's also being reflected. So make sure you're careful. And I'll give you about 90 seconds, 2 minutes to do that. And once you've graphed it, answer the questions. What's the line of symmetry? What's the domain and the range? What's the maximum or minimum value? Go ahead. What's your question?
You want us to draw a line to use the 5 times 2 to negative 10. You want us to just draw a line down?
Yeah, just do your best guesstimate. All right, so I've taken this in phases and pencil on my graph. I've done the basic graph talked about. And then if you have to do intermediate graphs, that's totally great. I told you to do multiplication first. So the first thing you do is you multiply all those y values by -2. So the basic graph has a y value of 1. So when I multiply that by -2, it becomes -2. It gets stretched and it gets reflected. This y value is 1. When I multiply by -2, it becomes -2. This y value of my basic graph, let me point to this one over here. This y value of the basic graph is 4. When I multiply that by -2, it becomes -8. So I got a dot down here. And I did the same thing on the other side. So this black parabola, that has been stretched and reflected by a factor of -2. And then you told me earlier the vertex means I've gone right 3 and up 5. So I took this black graph right here and I went right 3. I counted properly this time. So congratulations to me. And then up 5. And then I did that to all the points. So this blue graph is the graph. So then what's the line of symmetry? The line of symmetry is the line x equal to what number? 3. Yes, it's always the x value. Whatever the x value of the vertex is, that is going to be the line of symmetry. What's the domain of the blue graph? Negative infinity to positive infinity. Yes, indeed. That's always going to be the answer for a parabola. Yes. The range. Now this one, what's the low value of this graph right here? Yep, negative infinity. And then what's the high value of this graph? Okay, so the the range stops at 5. And then we kind of just answered the question, but I wanted you to see this graph's pointing down. What feature of the original function tells me before I even graph it that it's pointing down? The negative. So that means it has a maximum. A maximum, and the maximum value is 5. We got one more quick thing to talk about from this section, and then we're going to call it a wrap. The last thing that we're going to do is sometimes there'll be some situations when you're in some, when you're applying the idea of using parabolas, or you're doing a maximum or a minimum, or excuse me, a maximization or a minimization problem that you don't really care about the graph. You don't care about the other things. You just want to know what the vertex is because you want to know what the maximum or the minimum value, what they are. And so in that case, that you don't really care about anything else, there is a quick way to get the vertex of any parabola. So you can see, I've started the definition for you. The vertex formula So it starts off, I've written already, the vertex of the graph of p equals ax squared plus bx plus c is given by the following point. Okay, so if you've got your function in standard form, you can't just read what the vertex is, but that's what you want. Here is how you find the vertex. Okay, so I'm going to use v for the vertex. What it entails is you use this formula to find the x coordinate. It's negative b over 2a. That might look sort of familiar, and that's going to relate to our next section that we're going to start today. Then the y value, now this is fancy notation, but all this means is to get the y value, whatever this x value is, you're going to plug it into the function. And so you're going to find the polynomial's value at negative b over 2a. Okay, so that's fancy. Okay, don't let that confound you. All this means is you're going to use this formula, negative b over 2a, to get the x coordinate, and then whatever that number is, you plug it into the function to get the y coordinate. So I'm going to do the first example, you're going to do the second example, and then we're going to call it a day on this section, and we're going to start section 3.3. So the first example says use the vertex formula to find the vertex of this. F of x is equal to 2x squared minus 4x plus 5. And then when we're done with that, we're going to determine what is the maximum or what is the minimum value of this function. Well, I made negative b over 2a. So let's first identify what a and b are. So what's the value of a according to the standard form of this function? Okay, a is equal to 2. What's the value of b? Okay, don't forget that negative. I heard you say it, but I just want to make sure we're clear. It's negative 4. So the x value of my vertex is going to be negative b over 2a. So that's negative b. So negative 4, that is 4, over 2 times a, so 2 times 2. Negative b over 2a. This negative is part of the formula. This negative was the value of b. So negative and a negative make a positive, in case you're wondering where the sign went. And so now I have 4 in the top, I have 4 in the bottom. 4 divided by 4, your calculator will tell you 1. There's my x coordinate, my vertex. So I'm going to come over here, v for vertex. I'm going to put my x coordinate. Now I need the y coordinate. And all you do to find the y coordinate is you take that x value and you say, okay, I'm going to plug it in. So what is the function value at 1? Well, it's 2 times 1 squared. Minus 4 times 1 plus 5. 2 times 1 squared is 2. Negative 4 times 1 is negative 4 plus 5. 2 minus 4 is negative 2 plus 5 is 3. So the y value that goes with the x value 1 is 3. That's my vertex. This also works good if your vertex is going to be a fraction. Or a decimal of some sort. So I also ask you here, does it have a maximum or minimum value? So first tell me, this parabola right here, is it pointing up or is it pointing down? How do you know it's pointing up? It's positive. So since it's pointing up, that means I have a maximum or a minimum value. Got a minimum. And the minimum value is just that lowest y coordinate, which is all right, last problem from this section. Please do exercise 8. All right, so this last exercise for the section gives us this function, negative 2x squared minus 6x minus 5. We are asked for two things. What is the maximum, or excuse me, what's the vertex and what's the maximum or minimum value? So first, I'm going to identify the numbers that I need. The value of A is negative 2. The value of B is negative 6. So negative b over 2a, this is what's going to give me the x-coordinate of the vertex. So I have negative b, so that's negative negative 6. A negative times a negative is positive 6. 2a is 2 times negative 2. And so that's 6 over negative 4, which is negative 3/2 or negative 1.5. Either way you like it. Doesn't matter to me. I'm going to stick with the negative 3/2, but if you use the decimal, we'll come out with something equivalent. You all got calculators, so this isn't too torturous, just a little bit. So now what I'm going to do is I'm going to say, what's the function's value at negative 3/2 or negative 1.5? So that's negative 2 times negative 3/2 squared minus 6 times negative 3/2 minus 5. Or if you have 1.5s where I have negative, or where I have 3/2. Okay, so negative 3/2 times negative 3/2 is 9 over 4. A negative times a negative is a positive, and 6 times 3 is 18. 18 divided by 2 is 9. Negative 2 times 9 is negative 18 over 4, and I can reduce that just a little bit to negative 9/2. Again, if you've got a decimal, then that's negative 4.5. And last but not least, negative 9/2 plus 18/2, that's 9/2, minus 10/2 is negative 1/2. I believe if I've done my fractions in my head, which is super scary. And if you don't remember how to work with fractions, I got some videos on my YouTube channel. Just email me, I'll send you some links, and you can get a refresher in using fractions, or if you just use decimals in your calculator. Either way, I'm happy. So the vertex is negative 3/2 and negative 1/2. So which way does this parabola point? Does it point up or does it point down? Some points down. So since it points down, that means it's going to have a maximum. And what is that maximum value? The largest value is going to be just this largest y value right here, negative 1/2. Doesn't seem very large. All right, that is the end of that.